Hello students, in the last class we had seen what is an AP and the formula for nth term of an AP. Nth term of an AP, which is given as Tn is equal to A plus n minus 1 into D, where A is the first term of the sequence, n is the number of terms, and D is the common difference. So let us see some of the problems on this. So first problem, find the nth term in each of the following cases. And hence find the 25th term, and hence find the 25th term. So the first sequence is given to you here, 10, 13, 16, 19, and so on. Now obviously this is an arithmetic progression because you can see the difference between each consecutive terms, like difference between 13 and 10, that is 3, 16 and 13, that is 3, and so on. So here A, the first term, is 10, D, the common difference. So that is the second term minus first term, that is 3. So Tn is A plus n minus 1 into D. So 10 plus n minus 1 into D is 3, which is 10 plus 3n minus 3, which is 3n plus 7. So that is the general nth term of this AP. So to find T25, 25th term, what I'll do? I'll put n is equal to 25. So that is 3 into 25, 75 plus 7, that is 82. The 25th term of this AP will be 82. Take the second problem here. 97, 94, 91. So in this case you can see that the terms are decreasing. That means surely the common difference is negative. So here A is equal to 97, and remember that the common difference is always second term minus the first term. So that is negative 3. And hence the nth term Tn is A plus n minus 1 into D, which is 97 plus n minus 1 into negative 3. So 97 plus n minus 1 into negative 3. So open the bracket. N into negative 3. Negative 3n and minus 1 into minus 3, that is plus 3, which is 100 minus 3n. So that is the general nth term of this AP. And now I want to find out the 25th term, T25. That will be 100 minus 3 into 25. So that is 100 minus 75. And that is 25. So 25th term of this particular sequence will be 25. Now let us take the second type of problem here. Now find the number of multiples find the number of multiples of 3. Those are between 200 and 500. Now keep it in mind in such problems, number of multiples of 3. So they will increase by 3. Take for example, first multiple of 3 is 3, second is 6, third is 9. So this forms an AP. Now I want the first multiple of 3 that is just greater than 200. So the easier way is just on your calculator divide 200 by 3, which is 66.6. Now take the integer part 66, which will mean that 66th multiple, 66 into 3, which is 198, and it is less than 200. I want the first multiple of 3 that is greater than 200. So I will go to the next integer, 67 into 3, and that is 201. So the AP will start from 201. So the next multiple will be 201 plus 3, that is 204, 207, and so on. So what will be the last multiple? So divide, I want the last multiple of 3 that is just less than 500. So divide 500 by 3, you will get 166.66. So take the integer part 166 and multiply it by 3, and that will be 498. So when you want to find out the first multiple of 3 that just exceeds 200, divide 200 by 3, take the integer part and go to the next integer 66. That means go to 67 and multiply it by 3. That will be the first multiple of 3 that will just exceed 201. And to find out the last multiple that is just less than 500, just divide 500 by 3, take the integer part and multiply it by 3, and that will give you 498. So as you can see here, you get a arithmetic progression with A is equal to 201. Now because the multiples of 3 increase by 3 each, That means d will be 3, and in this case the nth term Tn will be 498. So use Tn is equal to a plus n minus 1 into d. So Tn is 498, the last term, nth term, a is 201, and I want to find out number of multiples, and d is 3. So first take 201 on the other side, 498 minus 201, that is 297, and that is equal to 3 into n minus 1, which will mean n minus 1 is 297 divided by 3, which is 99. So n is equal to 100. And that will mean there are 100 multiples of 3 which are between 200 and 500. Between 200 and 500. Now, let us come to the next type of problem. Now here, show that 714 is not a term of the sequence or of the AP. 5, 12, 19, and so on. Okay, now here what I will do is I will take suppose the nth term of this AP Tn is 714. So I will say let Tn be 714. Now use Tn formula. Tn is equal to a plus n minus 1 into d. That is 714 is equal to 5 plus n minus 1 into. Now here what is the common difference? D 12 minus 5, which is 7. So into 7 here. So take 5 on the other side first. So 714 minus 5, that is 709, and that is equal to 7 into n minus 1. Divide by 7, you get approximately 101.3, and that is equal to n minus 1. So n is equal to 102.3. Now, n is the number of terms. So, tell me, is it possible the number of terms is 102.3? No, it is not possible. Why? Because the number of terms should be always a natural number. 1, 2, 3, and so on. I can't have a decimal fraction as a number of terms. So, this is not possible. And what does that mean? That means 714 is not a term of the given AP. Okay, so is this concept okay with you? So whenever it is asked to you to show that a particular term is or does not belong to the given AP, take Tn as that particular term, and finally you'll get n as some decimal fraction or a fractional number, but number of terms should be only natural numbers like 1, 2, 3, and so on. So you come to a contradiction, and hence it is not a term of the given AP. So let me give you some problems for practice here. So the first one, find the nth term and hence the 30th term, hence the 30th term of the AP. First one, 12, 21, 30, and so on. The second one, 4, -1, -6, and so on. Second problem, the nth term of a sequence is given as un is equal to 5 minus 3n. Un is 5 minus 3n. Show that it is an AP. Then now in this problem, to show that it is an AP, what will you do? In order, try to find out 3 to 4 terms and then show that the common difference is constant. Then third term, find the number of multiples of 7 between 300 and 900. So to find out the first multiple of 7, that is just greater than 300, you will divide 300 by 7, take the integer part and go to the next integer and multiply that by 7. And to find out the last multiple, that is just less than 900, divide 900 by 7, take the integer part and multiply it by 7. And the fourth problem, show that $382 is not a term of the sequence, (20), (29), (38). So here, first take Tn as 382 and you'll get n as a fraction which will contradict. So it is not a term of the sequence. So just try these problems as a homework. Any doubts, make them clear in the next class. Wish the concepts are becoming clear to you. See you in the next class. Enjoy the day ahead. Bye, students.